Hello and welcome to this tutorial. We will give you today an introduction into the component and entity system of CryengineHUMBLEBUNDLE. We will create a simple project, how to use the components, how to combine them together, and how to create your own custom components in C++. We will start off first with creating our project. We will just go into the launcher and click on New to create a new project. We will use the CryengineHUMBLE 5.4 version and select the rolling ball template. Then just save it to some location you want to have it. For me, I will stick with the default settings and just name it tutorial and just create it. So now just launch it in the editor and we are good to go. So the first things I will do is I just give you a short introduction to the entities in the sandbox and how you can use components. So what we want to do, we want to just create a new level. So we have a blank start and we call this tutorial and just keep the default settings. Now we are in the sandbox and as you can see, nothing is in here. It's empty and we want to start off making some cool objects or some logic into this level now. So what we're going to do is we create an empty entity on the left side of the create object panel. Click on it and drag the mouse into the sandbox. Click again and now the entity is placed at that position. But the question now is, what is an entity? An entity really in CryengineHUMBLE is only a container for data and logic. And it only consists out of some really generic default settings. For example, the general information, which contains the type of this object, the name of the object, which for example is entity here, and we can rename it to my entity, for example. We have the colors, we have the layers. The layers are just a way to sort your different entities. If you want to have some sort of group settings, you can just use that one. You can use override materials or set any specific graphic settings for this entity. The entity also consists out of a transform for itself. So if we, for example, manipulate this data here now, you can see that the entity is moving in the sandbox and you can start moving up into the air and those sort of things. But as you can see, we don't have anything visible here. So if I jump into the game mode with clicking on this button, we only have the default rolling ball template ball, but nothing else in the scene. So first of all, what we want to do is we want to add a mesh component to this entity so we can actually see something in our scene. In order to do that, we just click on Add Component on the Add Component button in the Properties panel, click it, and as you can see, there are all sorts of different components already exposed from CryengineHUMBLE by default. We have a documentation page which covers all of those components, explain what they do and how you can use them. But we will just stick to the mesh component first and click it. So now you can see that there's a new panel in our properties window. And this is just now our component we added and it's called mesh. And as you can see, this mesh exposes all sorts of different data. As you can see, we also have a transform for this component, and that transform now is only relative to our entity. So if I move the entity again up here, you can see it's just an offset. So we just gonna revert that. And the next type is for different rendering and collider. We will just use that as a default because I won't go into details of all the different settings now, since that's just like experimenting. But what we want to do now is just changing the file, which is at the end the mesh we can see here in the sandbox. So click on this folder button, go to the objects, just select any sort of default object you want to have. Click on Thea, for example, you can see, okay, I have a Thea now, open it, and you can see, okay, now it changed. So now we can move this around and we have an actual visual representation of a mesh in here. We can also change the material, so it doesn't just say replace me here, just go to the folder icon again and select one of the assets we have here, materials, and we're gonna click on objects. Okay, so now it shows a like just default solid color material, and we pretty much have our first component and add the entity, and we can start working with it. So what happens now if we, for example, jump into the game mode? We have a visual object in here, but as you can see, there's no collision. There's nothing happening to it. It's just standing there around. There's nothing, can't click on it, you can't collide with it. It's just a mesh in the world. It's not really physicalized. So in order to physicalize this object, we have to add another component. And now you kind of can see where this component system is going. You can click on add component. And now we want to add a rigid body, which is just a physical object in the world then. Or the component makes the object a physical object. And we just go through here and click on rigid body. And now you can see we have the next component in our entity. It's separated from the mesh here. So this one is the mesh component. This one is the rigid body component. And now we can see that this rigid body component exposes also data. We won't just leave everything by default. And the only thing which is really interesting for us is the type. The type defines how the object behaves in the physical world. So static means the object won't move at all, and rigid means the object will be simulated in the world. So, for example, if we now hit the play button for the enable physics, you can see, okay, now the ball does something in the world, and I can see that it will be simulated. So, for example, if we hit into the game mode for a rolling ball now, we can hit this ball, we can interact with it, and in order to adjust the physical settings of this mesh, for example, here, we can go back to our mesh component and go into the physical settings, go to the mass, and for example, maybe change the mass to something way more higher. And now we should feel that if we want to hit this ball, it's already way heavier and it's harder for us to push it away. And that's basically how components also can be combined and how they, for example, look up for other components and see if there are already data they can use. So if, for example, if you only have a rigid body on your component, it won't do anything because a rigid body only uses the data which is on that entity. And if there's no data, it won't be physicalized. So you also need a mesh as we've shown here. Okay. So you can, of course, start working or just playing around with it. You can just see what do we have here as other components. There are, for example, lights you can add to your entity. There are different types of colliders you could add to your entity, or for example, you could also add particle emitters. But those are, if you once understood the system, they are pretty straightforward, and you can just play around with them, see what they do, and try to make something cool with the components. Since we now have those components on the entity, and we also kind of know how entities function in the world and how we can add components to it, we maybe just want to do something interactive with this object, because at the moment we just can't push it around. But it would be cool if we, for example, could click a button or press a key on the keyboard and the ball would just jump into the air. In order to do that, we just want to create our own custom C++ component. And as you can see, all those components are already predefined by CryengineHUMBLE, and they are all written in C++. And we want to do something similar to this. So we want to make a component which is some sort of a player component where you can press a button and the player will move up or do something. Okay, so we will just save the level for now and close the editor again so we can go into the code side and start implementing the component. What we want to do next to open the code, we just click on here on this icon to reveal the tutorial in the Explorer, which is here. And now you can see there's this game Cry project, which is your central project file for this specific project. And as you can see, if you right click on it, there are all different kinds of settings. You can launch it again in the editor or in game mode. But what we want to do is we want to generate a solution, which will us then enable to manipulate the code and compile it again. So just hit generate solution. This now will take some time. And if it's successful, it should just close. So generate the solution. And we'll just take a moment and should close the window again. And then you should have a new folder in your project. As you can see, it's called solution. And this folder now contains your Visual Studio solution where you can start changing the C++ code. So double click into it. Then we want to go into the Win64 folder. And now there are all sorts of different files, but we can ignore all of them. The only interesting file is for us the game SLN, which is the project file for Visual Studio. So launch up Visual Studio. So now we have, as you can see, the Solution Explorer for our solution we just opened. You can see with some CMake predefined targets, which we can just ignore. This is just stuff we need for generating the solution. The really important thing here is that we go to the project filter, click on the game stuff, and now you can see, okay, here's the actually game code. So as you can see, we have the game plugin in here, the CPP and the header, and the game plugin is responsible for actually loading the game into the engine, and then you can just like do the logic you want to do in that plugin. This code is the generic code we provide from default with the rolling ball template. So we don't have to change anything in here. What we want to do next, of course, is we want to create our own component. So we have to add new files to it. We will just add a new filter to our Solution Explorer and call it my component, and just hit enter and add the actually CPP file, which we just call my player component, and browse to some sort of location where you want to save that file. I just use the default code folder from that project. Select, add, and now you can see we added the CPP file. We just need the header file as well. Click on new item again, select the header file, go here and enter a new name, which would be my player component again, and add OK. So now we have the header and the CPP, and they're just empty, and we want to start off building the component from scratch. So if you don't know what to do here, it's, for example, it would be easy to just look up what we already have into the project, so you can see maybe how we did it before. So I could, for example, recommend just looking into the spawn point component, which provides already some code for the components. You can look into it and see what we did here. So, for example, what you could do if you just want to have your own component, you could just copy most of the code here and just work with what we have here. Just added your new functions, or whatever you want to have in here. But we just start from scratch and explain everything to do. So this one is the C spawn point component. This one already provides a default implementation of the iEntity component, but we want to do it from scratch. But this is just a help maybe for you. If you just forgot a single step, you can just look up how we did it. The first thing we want to do is here, we want to create our new class, which is just a container or the general class in programming, which our entity component will be then later on. So we just call this my player component, probably capitalize it in C, and hit enter. So now we have this, our default class. Just clean it up a little bit, just adding the default constructors and the default destructor. And now we only have the class, of course. And what we really want to have here is inheriting from the iEntity component interface. And this interface provides you with all the functionality the component we have like as an interface provides for you. So we want to include this interface first. Include the CryengineEntity system, which is just a folder where all those entity system headers are in. And we want to select the iEntity component. So this one includes now the interface, and if you press F12 or go into here and, for example, go to definition, you can see how that entity component is implemented. This iEntity component is a class or an interface, to be more specific here, and we want to inherit from it. So just add the iEntity component here. And now our myPlayer component inherits from the, let's just see that there's a mistake here. Never mind. Fixed it. Okay, so the iEntity component now inherits here the myPlayer component, and we can start using all the iEntity component functions. So the first really important thing to do after you inherit from the iEntity component interface is reflecting the type. But what does that mean? It does mean that we explain specifically what this component at the end is, so the engine knows, okay, what could the user, for example, use the component for, or what's the name of the component. All those things will be added in the reflect function. So you just type in static, and those are just the default settings, the default function which the CryengineHUMBLE wants to have. So we just use the C type description, which is just a struct which contains all the type description for our component here. This function. And if you for example want to know how we did it in the spawn point component, you can see okay, there is already this reflect type function I just talked about. It reflects the type of that component, and you can see what you really need to have here. So it's in the schematic namespace. And we can start now using this description. And this description is just a parameter, which is like at the same time the output for this function. So if we want to add any information, we just have to use this parameter, this struct, and use the functionality it provides already. So as you can see, there are all sorts of different functions for this descriptor. And you can just look through and maybe, for example, find functions which are already helpful for you. So what we want to do first is set the GUID. And this one is a rather specific case for CryengineHUMBLE, but we have to do this here in order for the sandbox to have a specific identifier for this entity component. So for example, if you have 20 components and they could all be named my component, for example, but the engine has to make a difference for those components. Like if you, for example, load those components and all 20 components are called my component, it doesn't know which component it should take. So what we need here is we want to add a GUID, which is a global unique identifier for this component. So the sandbox knows, okay, this is a specific component, and I can just remember that GUID every time. So, but how do we add the GUID? There's already a built-in feature by Visual Studio, and you can go into Tools, go to create GUID, and we just select the fourth one. And as you can see, it already generated a new GUID here. We just copy that one and enter it, and just enter it into our set here. What we also have to do is using just want to have to use the literal here, which is just a way how we transform those data into something the engine can use. But at the end, what you want to do if you create your new component, just copy an existing GUID and just go to Tools and generate a new one. Right, so, oh, oops, my mistake. This quote should be here and not at the end. So now we have our GUID, and that's literally it. We don't have to do anything more for this component technically. So now it's just empty and you can't do anything with it, but that is already enough to create your own component. We have a global identifier, and we have this class really. But of course we want probably to do more stuff with this. So the next thing we probably want to do is add a name or some sort of name, so you know what this component is called. So what we want to set label, and the label is the label of this component in the sandbox. So we just call it my player component. We added this label to our description, and this description then will be later used by the sandbox and by the engine to reflect our component. So it has a name and a GUID, and that should be, for the beginning, should be enough for our reflect type function and for this component. The next step we want to do is, of course, we want to implement our own logic for this component. So we can use already provided functions from the interface. That would be, for example, initialize, which will be called, of course, we want to override it. So we just use virtual initialize. This one will now override the initialize function of the interface of the iEntity component, and the initialize function will always be called if the object gets created the first time. So it's just initializing the object, and you can start adding your own logic in here. And this one will be called if the sandbox or wherever you create this component the first time. We go into the CPP now to implement that function. And the first thing we have to include is the standard compiled header. And this standard compiled header is nothing more than just standard information about the engine, about allocators and all those things. But this is nothing you have to worry about. Just include that header and you can use all the standard things CryengineHUMBLE exposes to you. The next thing we need is, of course, including the class we just made. So there's my player component. And now we want, of course, to implement our initialize function. Initialize. And now we can, for example, start here to implement our logic. For example, if we start making, I don't know, we could log something in here, cry log, and that would, for example, be like my component in the log or in the console. You could, for example, see it now that this one gets initialized. So if you ever have the feeling, oh, it doesn't get called, you can just use cry log and have maybe see it in the console. And if you don't see it in the console, you might have the problem that this function won't be called. So now we have the initialize function here. And as we can see now, it's in the header, it's implemented. And we can start implementing our own logic. We want to, of course, have some sort of input for our component. And in order to get input, we have to create a new component on this entity. So this component here will be later on, of course, part of an entity, as I've shown it before in the sandbox. We want to add input to our entity. So we can, for example, click any button and we jump into the air. So to add input, we have to include a new header file, which is in this case just the default components. And there we just want to go to input and include the input component header. So we just want to create our component. So we create a stack variable or just a pointer to this, call it input, and we create now this component from the entity. So you can see if I just mp entity, this entity will be the entity of where the component lies on. So this one is the container of your component. And this entity also, of course, has the transformation. So if you get position, you can get the position. But what we want to do is get or create component. And this function, as it already says, it gets or creates a component. So if we already have an input component on the entity, we just get that one. Or if we don't have one, we just create a new one. This is just helpful so we don't create like multiple components accidentally. So just type in the default components and then the input component, which is just a template type here. And now we will create the component, the input component here, and we can start using now this input component. The next step here would be to register an action. Or let me first comment this so you guys can follow it up better. Like create input component from entity. And now, as you can see, we have this input component and we want to start adding an action to it. And what is the action? An action really is just a specific part of logic where you can implement, which will be executed if a button gets pressed. So it's some sort of a function pointer for people who know C++. And I will go into this in more detail after we implemented it. So the first name is the group name. Our group is, I don't know, player or my player or something like that. And the next thing will be the name of this action, and we just call it jump. The next parameter we need to fill in for the register action is now our SD function, which is at the end what we use is a lambda here. So we use this as a like as a parameter. We put in the activation mode, and the activation mode will be set in by the calling function. For example, if the input system now sees, okay, I registered this input, I have to call this function, the activation mode will be sent to you with this function, and it will also include the value, which for example could be any sort of, for example, mouse wheel, the delta of the mouse wheel, or the position of your mouse. So finish this up, and now in those brackets we can start implementing the actual action. So what should happen if this action gets called by the system? We want to push the player into the air, but how can we do this? As we remember, we have the ball, which is just like rolling around in the level, and as you can remember, there was a rigid body component on this entity. And the rigid body component, as I said earlier, is responsible of manipulating the object and adding it to the physical world. So what we can do is we get the rigid body component, which is already on our entity, and we can start adding, for example, an impulse to this rigid body. And the rigid body already provides a lot of functions which you can use, but I show this in a second. So first, we just want to do the thing we did before. So we just create a stack variable, which is body component. Well, yeah, of course, we have to implement this as well. So we go back into here, include default components, and we want to get the physics, and there we want to get the rigid body component. Now we can start using the rigid body component here and get it again. This is fine. Okay, so we just get the component again from our entities. So get or create component, copy this thing here, and we can get the rigid body component here. So this one definitely now consists out of our component we added earlier in the sandbox, and we can start using this component now. And as you can see here, IntelliSense already provides the functions which are implemented for this component. So as you can see, there's all sorts of different stuff. But what we really want to do is add impulse, because add impulse would just add a force to this object in the sandbox. So we just apply impulse function, and as you can see, it wants a vector from us as a parameter. So just use the vector here, and we have to now give the direction of our impulse. So in which direction should the impulse go? And this, of course, depends on your game or what you want to implement. For example, we want to make the player jump into the air. So we just say 0 for X, 0 for Y, and 1 for the Z axis. And that one just jumps up the player, or just adds a force to the player into the air. So then we want, of course, to multiply this with some sort of force or multiplier, because this is not really a strong value. So, for example, we could add a super strong force, which would like 500 or 600, and then the ball would just fly off. But we just, for example, use something more feasible for this case. So we just create a const float force, and we just give it like 10 or so. I hope that's fine. And we just add it here. So now we pretty much already implemented the whole logic we need to make the player jump. It just adds a force to the player into one direction if a specific action gets called. So, but as you can see now, this is just registering it. There's no key value we can give into that function. How can we do this? We just have to bind this action now to the system. So it just registered that action, but that doesn't mean that we already bind it to the system. And the binding action then actually decides which mouse button or which key button we want to use. So we just go to the input component again, and as you can see, it's already provided as the first function, just bind action. And again, we just want to type down what we typed there, just jump. And the next thing here would then be the flag of the device. So as you can see, if you hover over the function, it says group name, and now the device key. And that's just an enum of all sorts of different devices. So for example, if you can see there's keyboard mouse, which is probably what we're gonna use, but there's also Oculus Touch, PS4 pad, or the Xbox pad if you want to use the controllers. We're just gonna stick with this one. And now we can decide which key we want to use. And as you can see, there's of course all keys on the keyboard, but for this example, we just keep with the one button, which is the left mouse button. This one is the whole code you need to register an input action, add a force to your rigid body component, which then will of course move the entity up, and then just bind this action to the system. So that is the logic for our component here, and this should already be enough. So for example, if we now create a component in the sandbox, click the mouse button, and then see what's happening, that should already be enough for this case. But the only thing which is missing here is, at the moment, we don't tell the system that this component really exists. So if we would now start a sandbox, it doesn't know that this is a thing. We have to first tell the CryeEngine that we want to register this component as well, so we can select it and use it in this editor. So how are we gonna do this? This is always the same, pretty much the same code for every component. It's just a default setup. So what I would recommend is just going to the spawn point component, going into the CPP file, which is here. And as you can see, this one is pretty much what we need to register that component. And you can just copy that because it's redundant code, and copy it over here into our function and just rename the register function. So we just call it my player component, and we have to register our class here. So this one is the actually registering part. This one registers the actually schematic component, which then can be used in the sandbox. And as we remember, this is my player component class. Just add it here, and then we want to register the right function here. So now, as you can see, it's like telling you that this is wrong. But why is it wrong? It's wrong because we're missing some headers which implement those schematic register functions. And I think just go back to the CrySchematic stuff. Those headers are all responsible for getting and reflecting types or functions or data for schematic. We're gonna need those headers anyway, so just copy them, and those are just default headers you need for your component. And as you can see, nice, it's fixed now. And the next step would really be compiling the solution and launching it in the sandbox. So to compile the solution, we go to build solution. Now the output should tell us how good we are at programming, and hopefully it doesn't throw an error, but it looks good, I think. So if this one is done, it should say succeeded, no failed, and we can start this in sandbox. And a cool feature we have since 5.4 is that like every different device we have or platform we have is already registered here, so we can just say like, we want to launch the sandbox, and we have to click on the right click on the project here and use the set as startup project. So if we now click on the launch Windows debugger button, it launches up the sandbox with our plugin. So that's fairly easy. Okay, so next step, just opening the tutorial level again we created before. And as you can see, our beautiful ball is still here, and we now want to add our custom C++ component to it. So just go back again, click on the entity, go to the properties panel, click on add component, and now you can see like, I see my player component, nice. Now we can see our custom component in the sandbox, and we can add it to every entity in the scene. So as you can see, okay, it already created that input component we talked about earlier, and it also created my player component. As you can see, it's empty, it doesn't expose any data, but we will do that later. And now let's see what happens if we jump into the game mode. So if we now jump. Okay, so if we jump into the game, we can see that if we press the mouse button, it really slightly jumps up into the air. Of course, the player rolling ball, which is by default into this in that example, jumps up, but also our other component kind of jumps it up. But what we want to do is either we go into the code and change the force there, since apparently the force wasn't enough. We could also just change the mesh settings in here for our entity. So we just go into the properties panel and change the mass to make the object a little bit lighter. So for example, 10 in this case. And now, after this is saved, we can jump back into the game, and now we can see, jumps up into the air. And if we play, of course, like click the button a lot, we just jump more and more into the air. So this is nice, and we can now see that our component actually works on this entity. We can see we jump into the air, we see that the input gets properly registered and binded to the system, and if we click, the ball jumps up. So what we want to do next, as we already saw that this force, we really would like to manipulate the force we added in the code. Like, yeah, now we had to change the mass, but what if we want to keep the mass as it was? That would be easy to just add a force attribute here to our myPlayer component, as, for example, the other components also have some attributes. And that's going to be done in the code again, or in the header to be more specific. So we want to save the project, go to File, Save. Now the project is safe, and we just close the sandbox again and go into Visual Studio to add the attributes to the component. So we go into the myPlayer component header here. And as you might have already guessed, the reflect type function also is responsible for adding your own parameters to the component. The attribute can be added here through the desc, which is just a descriptor of the reflect type, and as you can see, add member. So here we can add a member to our component, which then can be adjusted in the sandbox. But first of all, we of course have to create a member for this component. We just create a new member here, so we just call it M. It's a float for force, and the default value is just, 10. And now we can go back into the CPP code and remove the force we had in here, because we don't need it anymore. We have a public member now for it. Replace the force in here for the impulse function, multiply it just with the vector, and go back into the header. I mean, this now not really changed anything, but it's just a public member now. But now we can get that member into our add member function. So we just want to myPlayer component, the mForce attribute, and as you can see, the function takes all sort of different things from you. Like it wants an ID, it wants a name, it wants a label, and we go through every single one of those and explain what they mean and how you can use them. So the first or the next thing after adding your member from the class is adding the ID, and that's kind of comparable to the global identifier we had earlier, but now it's only an identifier for the member of this specific component. So what you can do is just adding those single quotes and add any sorts of like combination of characters. This one, then we generate an ID from, and this one then is a specific identifier for this attribute. So we're just gonna take for force, and you have to do this just so the system knows, like, okay, this is a specific member. But for example, if you have multiple float force attributes and the system doesn't know which one is which, we have to have some sort of identifier. So this one should always be unique in that scope here. So the next parameter is the name, and that name is just the name which will be used in the sandbox or in the engine itself. So we just take myPlayer component here again. And the next attribute is the label. This label will actually be used then in the sandbox. So you can see this is the label of the attribute we just added here for the sandbox. So we just add, for example, force here. And this one then just uses the force name as a attribute name for the sandbox, and you can see you can adjust it. And oops, that was my mistake. Of course, not my component. This is also force, since we just have the name for the inside engine and the name for the label, but those are the same, so we just keep them the same. The next step here would be adding a description. So now you could go crazy and like write a 2-page document about what this attribute is for, but I just say like force of the jump, for example, and that's enough for me. This description could, for example, be a tooltip. If you go over the entity property of this member in the sandbox, you hover over it, you get that explanation, and it kind of describes what the member could be used for. So the next attribute is the default value. If the component gets added to your object, you have to have some sort of default value, and that's what you put in here. So we just put 10 in here again and save our file with Control S here. And that's pretty much it for adding an attribute to your component. So after you've done that, you just go again to build solution, and hope that you didn't do any mistakes. But it says build successful, so I just trust Visual Studio on this one, and just launch the example. Okay, now we open our default tutorial level again and go click on the My Entity object. And as you now can see, super, we have our force attribute as a part of the My Player component, and we can start adjusting this value here, like just dragging the mouse or entering a specific value. So for example, if we now would enter only 1, we should see, yeah, as you can see, it's a really, really small impulse, but you can also add something more like stronger as 10, and now you should see it, yeah, it jumps up again in the air. So this is pretty much how you can add members to your component. And as you can see above here, and for example, for the mesh component, it has all sorts of different attributes you can adjust. For example, the rendering collide, this is just the enum. You can, for example, serialize enums here. You could, for example, just get string names for objects. So everything we done here can be, of course, done for your own component. Then the next thing we might want to do is just check out some of specific component flags, for example, since this component now it just has this force attribute, but for example, the mesh also can have the transform attribute, which is here, and maybe we want something like this to have. And there's a specific type for the reflect type function, where you can specify certain flags for the components. For example, you could get a transformation. So every component can contain a transformation, or it could not. For example, how our MyPlay component does now. So we just save the project again, close the sandbox again, and go back into the code. So we go back into the reflect type function. We just go again here to the descriptor and search for set component flags, and this function lets you set the component flags for this component. And you can have a look at the component flags here. I flags, E flags, of course. And now you can see all the flags you can use for the component. For example, you can client only, that's for networking. You can, for example, hide from inspector if you made your own component and for some reason you don't want to have it in the add component menu, context menu, just add this flag to your component and it won't show it anymore. You can, for example, add components as legacy, which then shows that those components are old and you should use a new one. If you, for example, have a new version of your own component, you can use that one. You can also do the singleton one. And this one tells the system that only one of this component can be part of an entity. So you can't have 2 players, for example, because that would make no sense. So we just add this as a flag to our component. And for example, we could also add a new flag, which would be the iEntity E flags again. And then we, for example, want to transform for some reason. So for example, if you have a mesh and you just want a transformation for it, you just use that one. So yeah, we just create that one. So this. Right. So now our component consists out of the singleton flag and the transform flags, and those flags now will be used if we recompile the solution, build again, and it should be done in a second. Perfect. Launch it again. And now you should be able to see a transformation on this component. So just go open, click on tutorial again, click on this, Now you can see, okay, cool. Now I can adjust the transformation. Of course, nothing happens now because you would have to implement what would happen if you change the transformation. For example, we could move the mesh around, but that's already handled by the mesh component. So it depends really on the use case you want to use the transformation here. But it's just good to know that the component flags, they exist, and you can start adding those and just play around with them. So yeah, just close the editor again and go back to the Visual Studio Code. And this should be already a fairly good overview about the component system and how to create your own components. I mean, if you want to add more members, for example, you could just add the next members. Just if you once got the concept, you can just start working with it. You can start experimenting with the different parts of the system. You can, for example, see what the descriptor just has more for you to offer. For example, you could add a base, which then would be a base class, kind of your class would inherit from this. So if you have a component and this is more a generic component, you could make a new one and add this generic one as a base, and then you don't have to re-implement all the functionality. But yeah, I would recommend just going over the different parts of this tutorial, seeing, maybe just experimenting with the parts, just playing around with components, creating your own components, and just adding more functionality. But something which is also really important for the components here is the event system we have for each component. So every component can receive events, and those events can just be utilized through the actual. First, you get event mask function, and then you process event function. Right. So this one should return a and 64, and as you can see, those two functions now are part of the iEntity component interface, and you can start implementing them. So what does getEventMask really do? So getEventMask is responsible for registering this component for a specific type of iEntity events. So for example, we don't send every event every time to every component because that would be rather slow. We just let the user register, or the component register, the specific event we want to have. And this one can be done through the getEventMask. So we go to the CPP, go to, and we just play component, get event mask, turn that, start returning a bit, Now we can just return the bit flag for this specific entity event. For example, if you type now entity underscore event, you can see all the events which are possible you can receive. So there are collision events. For example, if your entity collides with another entity, you can get a collision event, which might be helpful if you want to have some sort of exploding ball which explodes on collision. You get all sorts of more system events, for example, if your entity gets detached or deactivated. But what we want to do here is event update. So we can receive now an update call for this component. So we just use bit64, which just creates this bit flag for the iEntity event update. And we now want, of course, to also implement the component process event function. Okay, so now, as you can see, you already provide with an attribute here the event, and the event can be used to switch on it. So, for example, you just add a switch case here, add the event.event, which is kind of ridiculous, but it's just how it works. And this event now contains the flag the flag of this specific event. So, for example, if we would have multiple events we are listening for, we would just receive the specific flag here. So we just add a new case, and the case here would be entity event update. And now we can implement our update logic into this in that code here. So for example, if you want to move the player around, or you want to change the color of the player, or something which have to be done every frame, you can do this in the entity event update What we want to do here is just showing off what you could, for example, do in the update. That really depends, of course, of your use case, and we just gonna draw a really simple 2D text on the screen so we can see, oh yeah, this gets actually called. So we add a color for it, so just a container, so we have a color for the text. Just make it some color, it really doesn't matter. It's just, and then we call the global environment and the GN pointer. That one contains all the system in CryeEngine. So for example, if I go into here, I can see P entity system. It contains the entity system. It contains the, for example, flow graph system. And what we want to use here is we want to use the aux renderer. And that aux geom renderer is, for example, it's just helping you drawing simple geometry. So if you go here, you can see you can draw all sorts of different objects or just lines or text. And this one can be really helpful to debug certain stuff of your component. For example, if you have a collision size or some size of triggering area of that component, you could just draw an ABB or, for example, a cylinder to just see how big your radius is. But in this case, we just gonna pick the draw 2D label, and now we just put in some like default values. The font size is 2 for me, and just put in the color we defined before. We don't want to have this centered, and now we can put in the text. We just call this, yeah, I was updated. So this one now gets called every frame, and hopefully we receive this event, go through this code here, draw the 2D label, and we should be able to see it directly in the preview window. Okay, one thing I forgot here, which is important, is we have to go into the header and add a const to the definition of getEventMask. That's just how the interface exposes this function. And if you don't have that const, the function, the iEntity component interface can't pick up the function. So you have to be specific with the functions and how they are implemented in the iEntity component. So we just go back into the CPP again and just add a const here. And now we should be good to go and build the solution again. So build solution, wait until it's successful, and launch the editor again. And now we should be able to see the 2D text in the level. So open the tutorial level, and yay, we get updates events. And that's great, right? I mean, now, of course, this is fairly simple and doesn't really have any use case really, but this is just showing you how you could use those events for your own specific logic. So if we now go to here, you can see it was updated. And this one, of course, will update even though if you're not in the game mode. If you jump into the game mode, you can see it's still updated, but it's also updated in the sandbox. So for example, if you want to have a component which always or is only in use in the sandbox, and later on if you release the game, you just remove it, you still get update event in the sandbox, so you could do like some helper functions. So yeah, as you can see, we get the event here, and with the values, we have a transform, and this should already give you a fairly good overview of what you can achieve with components and how you can work with them. And as I said earlier already, with the knowledge you have now, you can start just iterating over what you learned, just start making your own components, trying to see what's possible, just fool around a little bit. It doesn't have to be something special, but if you once understood the system, you can start making your own components for pretty much every simple game you want to create. And that would be already it for the tutorial. I hope you guys learned a lot about the components. I hope you understood a lot of the component system, and I hope that the system we showed you like it and you can experiment with it. And something I want to show you before we head you off to just make your own awesome components is every component you can see in the sandbox is a default component implemented by us in the CryeEngine. So if you want to see how we did the own components, you can just jump to the GitHub page of CryeEngine, go to GitHub, go to the GitHub page, just type in CryeEngine, and you should get the CryeEngine source code here. And the components are all in one specific plugin, so they are in Cry plugins, Cry default entities, module, and default components. And now you can see all of those components you see in the editor are here available to just the source code to just have a look. And if you now, for example, go to the decal component, you can see how we implemented the decal component. And as you can see, it's not even that much code. So it's easy to just go through, see how we implemented some components. And maybe if you have a question like, how did they implemented this? You can just see like, okay, they added this or this type, or they just used this and this event. So that's a really helpful way to just learn more about the components and maybe even more about the engine in general. So that one is something I would really recommend for you guys. Just look into the components we already implemented and maybe just playing around with it, or just copying the code and adjusting it and just make your own, like a more advanced component than the default one. So now this is the end of our pre-recorded tutorial. Thank you.
Achieved with CryeEngine.